Re's a rewritten and refined version of your script with better flow, improved clarity, and an engaging narrative style suitable for a YouTube video on your channel, Waves Discovery. I've preserved your original intent while enhancing readability and coherence, and removing any repetitive or awkward phrasing. One of the most influential physicists of our time, Dr. Michio Kaku, has spoken out about a groundbreaking revelation that could redefine our understanding of the universe. Known for his contributions to both classical and quantum physics, Kaku has now confirmed a truly stunning discovery made by the James Webb Space Telescope: the detection of 6 massive galaxies that, according to existing scientific theories, simply shouldn't exist. This revelation is stirring up waves in the scientific community. These galaxies, so large, so old, and so luminous, challenge everything we thought we knew about the early universe. The implications are profound, potentially unlocking new layers of understanding about cosmic evolution and the fundamental laws of physics. Michio Kaku, a renowned American physicist of Japanese descent, has never been one to shy away from challenging established norms. While some scientists remain skeptical or overly cautious, Kaku has always embraced bold new theories, especially when supported by compelling evidence. And now, he's publicly praised the James Webb Space Telescope mission for what he sees as a pivotal moment in modern cosmology. In a rare public statement, Kaku emphasized how exciting these developments are, calling this discovery one of the most captivating scientific breakthroughs of the decade. His enthusiasm is hard to ignore, and for good reason. The discovery centers around 6 enormous galaxies observed as they appeared just 200 to 700 million years after the Big Bang. For context, that's a period when, according to prevailing theories, the universe was still in its chaotic infancy. It was supposed to be a hot, dense fog of particles, not a time when fully formed galaxies, especially ones larger and brighter than the Milky Way, could exist. These 6 galaxies are so extraordinary that astronomers have nicknamed them universe breakers. Why? Because if their existence is confirmed, they break nearly every existing model of galaxy formation and early cosmic evolution. They hint at either an older universe than we currently believe or a far more accelerated process of galaxy formation than previously thought. According to current models, it should have taken hundreds of millions of years for stars and galaxies to assemble in such structured forms. Yet here they are, massive, organized, and teeming with stars, at a time when such complexity shouldn't have been possible. Some of these galaxies appear to have formed hundreds of new stars every year, a pace that dwarfs the sporadic star formation in our own Milky Way. Naturally, this has raised serious concerns among those who uphold the standard cosmological model based on the Big Bang. Some scientists are even suggesting that the measurements could be flawed, or that redshift calculations, used to estimate the age and distance of these galaxies, might be off. But Michio Kaku is not convinced by these denials. He argues that science progresses by challenging outdated theories, not defending them at all costs. He's quoted as saying, "There are many examples of old, false theories that persisted purely because of the prestige of those who promoted them. Often, it takes just one decisive experiment to disprove decades of assumption. That is the nature of true science. It's built on the shoulders of experimenters who keep the theorists honest." Indeed, the Big Bang theory itself, developed in 1927, was a revolutionary concept at the time. It was born from observations that the universe is expanding, with galaxies moving away from us, an effect now known as Hubble's law. This expansion suggested a single origin point for the cosmos. Supporting evidence like cosmic microwave background radiation and the redshift of light from distant galaxies further cemented the theory in the scientific mainstream. He's quoted as saying, "There are many examples of old, false theories that persisted purely because of the prestige of those who promoted them. Often, it takes just one decisive experiment to disprove decades of assumption. That is the nature of true science. It's built on the shoulders of experimenters who keep the theorists honest." Indeed, the Big Bang theory itself, developed in 1927, was a revolutionary concept at the time. It was born from observations that the universe is expanding, with galaxies moving away from us, an effect now known as Hubble's law. This expansion suggested a single origin point for the cosmos. Supporting evidence like cosmic microwave background radiation and the redshift of light from distant galaxies further cemented the theory in the scientific mainstream. But now, the Webb telescope is revealing data that doesn't align with these assumptions. Instead of reinforcing the Big Bang model, it is throwing it into question. Kaku and other open-minded physicists see this not as a crisis, but as an opportunity, a chance to re-examine the foundations of cosmology. After all, science has evolved countless times. Once, people believed the Earth was flat, or that the Sun revolved around us. Those beliefs were backed by what seemed to be reasonable evidence at the time, until better tools and sharper observations proved otherwise. In a similar way, redshift, the measure of how much the light from distant galaxies is stretched as the universe expands, may not be as infallible as once thought. Like the Doppler effect in sound, redshift tells us if an object in space is moving away or toward us. But tiny errors in its measurement could lead to big miscalculations about the age and distance of celestial objects. Could these 6 galaxies be closer, or younger, than they appear? Or are we seeing real evidence that the universe matured far faster than expected? Either way, this is a question that demands rigorous investigation. Dismissing it out of hand would be unscientific. This isn't the first time science has faced such a challenge. And as Michio Kaku reminds us, the role of science is not to cling to tradition but to adapt to new knowledge. The universe, he says, is far more complex than Newton's laws or Einstein's equations alone can describe. Perhaps it's time to expand our models and embrace the possibility that the universe is older, stranger, or more dynamic than we ever imagined. So what happens next? Astronomers around the world are reviewing the James Webb data, recalculating redshifts, re-examining measurements, and preparing for peer-reviewed challenges. Whether these galaxies are true universe breakers or misunderstood anomalies, one thing is certain: we're at the edge of a potential revolution in cosmology. Thank you for joining us today on *Waves Discovery. If this topic fascinated you as much as it did us, don't forget to like, share, and subscribe so you never miss another deep dive into the mysteries of space and science. Drop your thoughts in the comments below. We'd love to hear your take on what these discoveries mean for the future of physics and our understanding of the cosmos. Until next time, keep your curiosity alive.